Good afternoon and welcome to Calculus in the PM. I'm your host, Mr. Shindelka. Today we're looking at 3.3, the rules for differentiation. Now, before we start, I guess you guys probably know or whatever, I'm famous for my, well, not famous yet, but I'd like to put in a little plug from our sponsor, and it's my own business, Papa Joe's Beef Burgers. You guys know about A&W's campaign. I think it's rubbish, right? What is it?
It's 100%
100% beef, yeah. No hormones or steroids. I would love to have beef with steroids in it, right? Because I'm a little guy. I need the muscle power and stuff like this. So my new promotion, message from our sponsor, Papa's all beef burgers, raised without any hemorrhoids. Hemorrhoid-free beef. I think that'd be awful. Our beef does contain steroids. Well, who wouldn't want bigger muscles, right? Papa Joe. That's me as a kid, by the way, 35 years ago. Taking a young calf in for slaughter. Anyways. It's actually a Jersey calf, so it'd be all just skin and bones anyways. Hemorrhoid-free beef. I've got to have a gimmick. How can I compete with A&W, eh? Anyways, back to this. Rules for differentiation. Now, first of all, we got to keep this in mind always, and I was just mentioning, sure, we're not talking limits anymore, but always keep this in mind. The definition of a derivative is the limit of h approaching 0. It's the slope formula, right? You're using the slope formula and you're applying a limit to it, moving it in. Okay, then I remember you talked about a description of the derivative. What is a description of the derivative? I said I'd remind you a couple times at least in the next week or two. The derivative is just a what? A formula or equation that gives you slope of a tangent line for a function at a given point, possibly. Once you get the derivative, you have a formula. And you just put in x equals 2 or x equals negative 3, and you've got the slope of the tangent line at x equals negative 3. Okay. So just always keep this in mind. It comes from a limit, and it gives you the slope of the tangent. Okay. Now I mentioned, and I'll repeat, this is an important section. You're going to learn the rules that are shortcuts, so you don't have to determine derivatives using the definition, the limit definition. If ever asked, though, using the definition, you will, but it won't be often, if at all. Keep this in mind, though, that it is a limit. Keep that in mind at all times when you apply the derivative rules. Okay, that you're actually evaluating the limit, okay? Now, like I said, it won't be in the immediate future that you have to keep this limit thing in mind, but later on, it might help you solve some more complex problems. Now, the first rule, and some people already knew about this because they might have had a brother or a cousin that was helping them or something like that and said, hey, there's a shortcut for this. We call it the power rule, and that's what we're going to look at today. Even then, this looks kind of confusing here, this power rule. But if the function f of x is x to the n, so x squared, then the derivative, that's our f prime notation for derivatives, is, what happens here? Where'd this front number come from the original front? It was the old exponent, right? Move that in front, and then reduce the exponent by 1. As long as this n here, and the first thing was a real number. It can be a fraction, it can be a negative. It has to be a real number, though. What does that mean? It can't be negative root, or the root of negative 2 or something like that. We complex numbers, which you guys don't study anymore since they've been outlawed by the government 5 years ago. I don't know, they took it out of the curriculum. Let's see this, though, and we're going to practice using two different types of notation. F prime for derivatives when we're given f. When it's given as y, we're going to use dy by dx, and it means the same thing, the derivative. It's just different notation. But let's practice this rule. So, according to this rule, x to the n, well, this is x to the 4. If there's a number in front, though, like 10, we're just going to say, well, this is, and don't put equal sign, this is separate, so I'm going to just put a comma here, but f prime of x. So this is not connected, it's not equals beside. is equal to. I'm going to write this one out fully so you see where it comes from. 10 times. Now you would just go to 40. 4, I brought down the exponent. X to the, this is what happens when I talk, I make mistakes. X, I already had it down. 4 minus 1 is 3. So you would jump into 40x cubed, yes. Right? Makes sense? That's how this rule is applied. So let's try this, but this time I'm going to use dy by dx notation only because y equals suggests that maybe I should use that notation. It's not f. And in this case, I'm going to write it out long ways. You're welcome to jump straight to the answer. I bring down the exponent, same as usual, -7. X to the. I subtract 1, so what does the exponent become? -8. -7 minus 1. Sometimes people, myself included, you make an odd mistake and you go to 6 accidentally because you're thinking positive numbers. Okay, so positive 21. That's a careless error if you make it 6. I think you do understand. Now, I'm going to show you a little, this time y equals 11 over x. This doesn't work with that power rule, does it? How could I write the x up top, though? 11x to the -1. So if you need to make something look easier to do, rewrite it. I haven't done any calculus at this minute, though, right? Now I am. So I'm putting in a comma there, just to make sure you know this is not equals. dy by dx. You could use y prime, but dy by dx is a better notation. Now I bring down the -1, multiply it, so -11. X to the -2. Now, I don't have to rewrite my answer, but if I did, I'm going to just use green, because maybe you're on a multiple choice kind of thing, and hey, x to the -2 doesn't appear here. What do you think would actually appear on a multiple choice question as a final answer? Yeah. Now, if you're asked to get rid of any negative exponents, maybe I might say that. You would do that too. Okay. So this is a D is a variation of what we just saw. So D, I'm going to rewrite this before I do any calculus. -2x to the -8. Then I'll leave a space here because it's not equals. It's f prime of x is equal to. Separate statement. And then I'm going to say, well, positive 16. X to the -9, right? So does everybody see how this is working here? I'm going to just get paper towel to, hopefully. Nope. That's the thing about doing math that Kim will have here. You never know what you're going to get. How could I rewrite this one so that it's 4x to the, what's the exponent when it's square root? Make sure it looks like it's an exponent, though. Don't write the half as big as the 4. Push it up. Okay, then I'm going to say f prime equals 1/2 times 4, which is 2. X to the? You said 3 answers. You sure of that? Okay, -1/2. Yeah. 1/2 minus 2 out of 2 is -1/2. Well, now that's my next question. I'll do this in green. So you could do this in 2 steps, and I suspect that you could just skip. But I'll say, well, this is x to the 1/2 on the bottom. Well, what does x to the 1/2 mean? Typically in calculus, you shouldn't have to clear the denominators of any radicals. I'll let you know if you do, but that'll be as rare as hen's teeth that you'd have to do that. By the way, if you don't somehow separate these. Now, mostly you'll have questions where it isn't like this. If you had an equal sign here, I will be no mercy. I will be upset, right? Because this f of x is not equal to f prime of x, okay? We're working sideways here. Typically, we work down in math, but that's the space for photocopy reasons. Now, I added in some. Now, 3x to the 0, what does x to the 0 mean? 1. So if you just had the number 3 or the number 5. Now, 2 or 3 ways of approaching this. Strictly by a rule way, I guess I'll use red. Well, we'll think of this in 2 or 3 different ways. 2 ways at least. If you brought down 0, right? You got 0, so 0 is 0. You don't have to do anything else. Now, I wrote it 3x to the 0 this time just to be perfectly clear. But if I had f of x equals 5, 0, negative 2, I don't care what it is. I'll even make it negative 5, okay? If I graphed negative 5, it would look like a straight line. What is the slope at any point on my straight line of? It's 0 all the way. If you have a constant, don't put any thought into it other than a little bit of thought. But I just made up a question. That's why I changed colors. Okay. So I really didn't need x to the 0, but if you're applying the, what happens is, before I used to say, well, f of x equals 3, just make it 0 automatically. And someone would say, well, how does that work with the product rule? It does work with the product rule if you represent 3 as 3x to the 0. It kind of works. How about this one, y? Let's use a different notation this time. I'm going to say dy by dx. You could also say y prime. It's not as common, but if you see it, it means the derivative. It's not. I like dy by dx better. You can see that more. What's the derivative there? Is e a variable, by the way? No. 2.718. Blah blah blah. It's a constant. So. Doesn't matter. It's a constant. 0? It is 0. You know what happens? How many of you thought it was 14e? Yeah? Okay. That's cool. Because that's why I don't want you to think that. Because this represents a number, right? It's no different than if I have pi squared. But you're more familiar with working with pi, so you're less likely to do it. But pi squared is a number, right? 3.14159 squared. It's just a number. And it's a constant. So if you graphed 7e squared, it's some number and it's a flat line. It's 0. Okay. Another way to show notation. What if I give, and I just say d by dx? You know that y for dy by dx when I put it here? Like there, dy by dx? That y represents 11 out of x there, right? So what if y was equal to x squared plus x to the negative 2 is really what I'm saying. So sometimes you don't have y equals. You'll just say do the derivative. This means d by dx. Do the derivative with respect to the letter x for this expression in the brackets. You guys follow me on that? It's no different than what you've been doing. So anyway, you see the x, you're going to do the derivative. So this I do need to put equals. Because the derivative of that expression equals, tell me. Okay, what's the first one?
We didn't get first. You can just.
This is just doing the derivative of x squared plus x to the negative 2. It's just another notation. 2x. 2x, yeah.
Minus 2x about 3. Negative 3.
Negative 3, and what is it in between? I heard plus and minus. Plus negative 2, but so minus 2. If you see that, if you put plus and then bracket negative 2, that's fine.
And you just do it when you have say bottom. If that's positive, you can multiply it.
Can you which?
Powers, the property of power.
Okay, I'm not sure.
That's multiplied with that.
Okay. You could factor from here, but I'm not asking you. Okay. Okay. Now, use the function from A to find f prime of 2. So if I just started right off the bat and I said, f of x is equal to this expression, what is f prime, so f prime of 2, the derivative at x equals 2? What would you do? Because mathematically, I know it's not too tough. F prime of 2 is equal to? Using the function from A. So, what is it?
6 was
Oh, do you know what, too? I don't know where this went. Okay, I had a cube there anyways.
6
I thought I had that. Whatever. Do you know what? I think I was using disappearing ink or something. Maybe, well, the video will tell no lies. Maybe I'm lying. Anyways, 40x cubed.
240.
So, 40x cubed, so we're going to put this in here. 40. 2 cubed is what? 8. 8 times 4 is? Shame on you. But at least you're trying.
320.
320. Yeah. 320. Okay.
I did 6.
Yes, you did. I knew it. You did. You read 2 plus 2 plus 2.
Yeah, I multiplied it.
Yeah, you both. Yeah. Anyways, 2 cubed is 8. Okay, there you are. Okay. So, what does this represent here? F prime of 2.
So f point as x equal to 2. The slope is 320.
Sure. We can use hands to actually, we'll just, because you're close and you don't see that somebody else was going to answer to. So. And that's great. I make eye contact with you more often because you're right up front. You're a good student. But so, reiterating though, that's a bigger issue. You know this. It means if I graphed 10x to the 4, and I drew a tangent line at 2, x equals 2, it would be very steep. 320 would be the slope of that tangent line, right? Yeah, it's practically straight up for our, we wouldn't have a very good graph of that. But yes, that's what that would mean. Okay. We could do these with subtraction and addition as well, like obviously if you got, and we've more or less been doing this here. 3 things, do it as 3 separate problems and just put them beside each other, right? Now I said do B, okay, so I'm going to just work up here. F prime of x. In my mind, or else we can rewrite it here. Maybe I'll rewrite it. I'm going to rewrite it. You'll get to the point where in your mind you'll just see, oh, 3x to the negative 1. If you're prone to making mistakes, don't do it in your mind. It's worth the extra time. 7, 8. I'm not going to rewrite this one for you. You guys tell me. What does that one turn into before I do calculus? Yep. Zach.
I'm going to say 7x to the power of negative 5 multiplied by 5.
Good. So the 5 stays down. That's the big thing. 7/5. I'm thinking 7/5. 7x, sure. X to the negative 5, right? Don't move the 5. Now the f prime of x here. I don't know if I could squeeze that in here, so I'll put it over here. Okay. So that's going to be equal to. Okay, I'm waiting for answers. Good.
92 plus 50 x negative 4 minus 7 minus 6 minus 6.
Okay. 7x to the negative 6 over.
There's a 5 which goes.
Aha! He is right. 5 5 times 7/5 is, yeah, okay. I was just pausing, see if you'd change it. Good. Now, do people follow what he did? -5 times 7/5 is -7. Okay, there you are. That's looking good. Stop me if I make a mistake. I often just trust people's answers and I don't even think about them. Okay. The next one. I don't have a rule if we have an exponent on a bracket. We got to play around with that. I'm going to move B up top too for a second here. Oh, sorry, I didn't mean to do that. I'm going to just move B above here so that we have some room to play around with this. Okay. That's all getting messed up here. We got to multiply this out first because I don't have any other way of dealing with this at the moment. We will, but we don't right now. So, squaring it out. Bracket, bracket. So I've got to distribute the 5x to the next group. 25x squared. Minus 15x, and then minus the other 15x. I'm doing this in my imagination. If you're not, write it out. Yeah, 30x plus 9. Then I could do the derivative. So C. That's F prime notation, so I'll use that. And I've got this part. Once you have that out, it's easy, right? 50. What about the 9? Yeah, nothing to put there, right? It's a constant. So I'm just going to move that over so I have a bit of space for the next one. Wait. Yep.
So 9, so you just throw the constant away then? Or?
Well, I'm doing the derivative as if it's 3 separate problems in a sense. The derivative of this is the 50x. The derivative of that is minus 30, x to the 0, so it's just minus 30. And that's because, let's think about this, if I graph just minus 30, that would be a straight line, and it's the same slope all over. So it's minus 30, it doesn't matter what the x value is. Now, think about 9. Now, I didn't draw an x-axis for that other one, but 9. Straight line, what's the slope at any point on that line? 0.
Oh, you're trying to find this one.
The derivative, the formula for the derivative, the formula for the slope of the tangent line, if it was just x at y equals 9, it would be 0 at all points, so nothing. Okay, I'm going to skip D, because it would be also the same thing, multiply it out first, then do it. E. Well, we've got to do a few things here, right? Because we've got division as well as multiplication. So I'd strongly suggest you multiply it. What do you notice about the top, though? It's a quick multiplier, isn't it? Square, or it's a difference of squares, yes. So I'm going to say this is equal to 9x squared minus 25 x to the 5th. I can't do this, though. I don't have a rule yet for division. Distribute the division then, right? And so 9x squared divided by x to the 5? Yeah. 9 x to the negative 3. And I know where you're ahead of us, and that's good. 25 minus 25, x to the negative 5. I haven't done any calculus yet, right? Just manipulation. So then, to finish E off, what's my notation? So I'm going to use dy by dx. Please let your notation match the given problem. If it was y, use dy by dx. If it was f, use f. Anyways, the only reason why you're doing this is it's simpler to do calculus with this, right? Still the same expression as what we had, and it better be if you know. Back to this though. As you said, 18. Negative 18. x to the negative 4. Positive 5 times 25, what? 25 and
27. Yeah.
3 times 9 is 27, yeah. You said 18, I thought you were onto something, you're right.
27,
Yeah, guys, good one. I saw arrows, I saw Emma's hand go up first, she gets the points. Thank you. What was I thinking, eh? I was thinking wrong, that's right. Okay, then negative 125. Or negative 25 times negative 5 is positive 125. I'm thinking ahead of myself sometimes. And then I double it up. Negative 6. Thank you. I make lots. It's hard for me to get 100% on any test because I make silly errors. Okay. F, the toughest part of this is the preparation, not the calculus too. Let's think this one through here. F. This will work in blue. I'm still talking f of x. I am not doing calculus, but I want to, well, what do we think of that first chunk? The root of x over 3.
It's x over 1 over 2. Also, it's x over 3, bracket 1 over 2.
Okay, I'm going to write down what you say it again. And maybe it's right. I'll just write down exactly how you say it. Okay, tell me.
X over 3.
X over 3.
Full bracket.
Around it?
Yeah. 1 over 2.
Okay. Is that any easier to do calculus with?
No, you can then do x 1 over 2 and 3 over 2.
Aha. Okay. Okay, I'm going to keep it as over root 3 then, because it's still going to be in the root 3. I got it now. Yeah, I see. It's a two-step thought process kind of thing. Good. So, I'm going to call it like this. And what you said is totally right. So I'm going to think of this. Would this be the same for the number? And then x to the 1/2? Or you could just say 1 over. I'm doing this because what if it was 2/3 inside there, right? Mind blown. Okay. You could also say okay. 2 or 3 ways of thinking of this. The x to the 1/2 part right away. But I'm thinking, I'm leaving the numbers behind. That's what I'm thinking. Numbers separate from the x. This means, though what I covered up momentarily, it'll dissolve. That is what's here, right? X to the 1/2. That's all that I'm worried about. Okay. How about the -2 part?
-2.
Thanks, Emma. I think it was Emma, I heard.
Yes.
I didn't turn. Okay. Plus 6. I think this is right, isn't it? Yeah, you guys are good about stopping me. Don't ever hesitate if you're not sure of something. I might have made a mistake. Okay. I bring out down the exponent 1/2 times 1 over root 3. So I'm just going to call it 1 over 2 root 3. We don't care beyond that. If we need to manipulate it, we will, but we don't. X to the negative 1/2. We'll leave it at that for now. We know that if we need to, we can put it down and so on. Then the next one, what's this?
Plus x.
Plus, okay, good.
X.
Good, because 2 times 1/2, yeah, x.
To the to 1.
Let's think this here. I'm thinking arithmetic. Negative 1/2 minus 1, so 2 halves.
Oh.
That's cool. Maybe I will rewrite this one just so we can interpret what that means. 0. Okay.
6
Okay, this is where that exponent came from, right? Let's rewrite this one just in case you ever had to evaluate this with something in there. If I said what's x equals 4, what's the derivative at 4? Well, This is the same as, well, x to the negative 1/2 means put it downstairs, right? And it becomes x to the positive 1/2, but really, that's under our root sign. Can I do two things at once? Meaning, if this is a root, 3, and we have then root x on the denominator, 3x is under a root sign. Smokes, I heard that, you know. 3x. I'm just putting them side by side. Now, if you wanted to think of that as two separate things, root 3 times root x, it's still valid, it's still the same. Plus, what the heck is x to, I know it's 1 over, and then it's positive 3x.
X cubed root. So root x cubed.
Oh, root and then x cubed, you could do it one of two ways. You could do it this way, square root, and then
X root x.
this cubed, right?
With the x root x.
And it depends on the number. I would suggest, if I gave you the example of 4, I would do it outside. If it works better the other way around, then do it. Now, it's the same thing. Remember where I said, what if I said, what's f prime of 4? Would you agree that it would be easier to do it this way, to do the square root of 4 first, to get the number 2 and then cube it for 8? The other way would be 4 cubed, so it's 64. That one isn't bad, because you could do 4 times 4 times 4 in your head. But if it was something, if you get larger, sometimes it gets tough, right?
You can just solve the.
You can solve it either way, though. It's valid to have the cube inside or outside. Anyways, we're good on this? Good gravy. Now what? Find the coordinates of 2 points on the graph, blah, blah, blah. We're given a function. It's a polynomial. Is it quadratic? It's cubic, okay. My eyes aren't great. At which the slope of the tangent line is 6, so I'm telling you what the slope of the tangent line is. Hey, isn't this way easier, by the way, than doing the limit of h approaching 0?
Yes.
Oh, yeah. But you still, if you're ever asked to use the definition of the limit, you will. Okay, anyways. First says slope of the tangent line is 6. So what we need is a formula that gives us the slope of the tangent line. We call that the derivative, right? So we've got to find the derivative. All right, I'll get rid of this. I was just moving this up top. So f prime. I hear you're working it through. 3x squared plus 6x minus 3. Is that correct? Okay. Then what? I am told something in the problem. The slope of the tangent line is 6.
So you could put 6 there and add 3 so that you know.
Okay, well, just a second here. We'll put 6 there. Why 6? Because the slope of the tangent line is 6. And we're told that the derivative is the formula that gives you the slope of the tangent line. So I'm going to put 6 here for the value. And here's that formula that gives you the slope of the tangent line. It's called the derivative. I'm circular talking, right? Just have a taste of my dill pickle Coke. Refreshes. It's served at Papa Joe's Burgers. Anyways, back to this.
So it's not f of prime bracket 6, it's just 6 flat out?
Right. As a matter of fact, definitely not 6. We're trying to find the x value. F prime of what gives me 6 is really what we're asking. Well, that's the x coordinate. And then there's a bit more to it, but anyways. Now, I heard you say 9, and there's a reason why, because you're going to solve a quadratic. So you subtract the 6 so that you have 0 on this side. So I accidentally drew a line through. So 0 equals 3x squared plus 6x minus 9. This is what Paul was talking about. I think you guys know how to solve a quadratic. I would factor out the common factor of 3 first.
It's 9 and 3. 9 and negative 3.
You're fast. 2 brownie points. we're convinced that you're good. X plus 3, x minus 1, right?
Yeah, right. 1.
So I have two possible solutions for these factors, right? If x plus 3 equals 0, that meant that x was negative 3. Or x was equal to positive 1. Then you take a look. Does this answer my question directly? Almost. 4 to 5 right now.
Coordinates, you have to put it back in there.
Coordinates. Now, which do I put it back into there? Which one, the f prime or the f?
And the F.
F, because all f prime is describing is the slope of the tangent line at those points. If you put negative 3 or 1 into this equation, you'll get 6. At least we hope we would. So all we need to do now is find the coordinates. I'll use a different color here. F of negative 3, and that's just arithmetic. 27, negative. No, just say negative 3. Yeah, negative 27. Plus 27. That makes it easy. Minus, plus, actually, nothing. So that's the arithmetic there. We've got negative 3 comma 9. Okay, so that's equal to 9. I'll just put this here and then do the other one. F of 1, well, that's easier. 3 minus 3, yeah, it's 1. Okay, so my coordinates, 2 points, the graph or the slope is, okay, or the slope of the tangent line is 6. The coordinates are 1 comma 1, negative 3 with 9. Okay. Now, I know some of you work and I do this, I run out of space, so I start working left then right. Make it easy for me. Only circle one final answer, if there is only one, and Zach, you're the guy I'm talking about. And you're good about that.
I
Now,
always do it because I know I can't even mind.
you write bigger, I write bigger too, and you run out of space, and that's fine. I also will talk to you in a minute. I'll stop the recording. Now,